All right, section 3, we are going to talk about the tangent to a curve. What? All right, so don't write this. Let's just talk about it for a minute. What if you were asked to find the slope of a curve? Did you do it? Does it make sense? Not really, right? So we've been doing slopes of straight lines, right? Lines are straight, curves may not be straight. But that's exactly what we're going to do. We're going to be using limits. So let's think about geometry for just a second. Do you remember that a secant was a line that intersected a circle at 2 points? And a tangent was a line that intersected a circle at just 1 point. We're going to extend this to a curve, to any curve. It doesn't have to just be a circle. Let me take you to Desmos real quick and show you what we're talking about. All right, so here's this curve, right? What the red line right there is the secant line between these 2 points, right? Between this point here and this point here. That's called the secant line. And if we take one of the points and we slide it towards the other, and I take it and I take it and I'm moving, the x values are getting closer and closer to this first point here. Do you see that this secant line that was between these 2 points has now become, if I move my x values closer and closer to the other x value, now that red line is the tangent line at this point right here. So that's what we're going to be doing. We're going to be using limits. We're going to take the limit as this x, not that one. Let's say the x value is over here. My c value is over there. And I zoomed the wrong way. Lovely, there we go. So I'm going to take this point, and I'm going to be taking the limit as this x value gets closer and closer to this x value. And that's what will give me the tangent line at that point. All right, so the secant line becomes the tangent line as you take the limit as x approaches that other value. So now you can start writing. Let's start the notes. What we want to do is we want to make the secant become the tangent. So here's this curve. I've labeled 2 points. I've labeled P and I've labeled Q. P is the point that corresponds to an x value of C, and Q corresponds to an x value of x. And here's the secant line between P and Q. And so what we want is, all right, what's the slope of this line going through P and Q? And so I'll label these points. P is actually when x is C, your y value would be f of C. And then Q will be the point that when x is x, then your y value would be f of x. That's what we're saying. So f here at this point P, it's C because your x value is C, and then f of C. And so the slope is just the slope you've learned since whatever, a very long time ago, right? 6th grade, 7th grade, 8th grade, I don't know, where it's y minus y over x minus x, right? And so we take the y value f of x minus the y value f of c, and then divide it by the x minus x, so divided by x minus c. Now, so that's the slope of this secant line, right? And what we want is we want the tangent line. We want the tangent line here. We want the slope at when x is c. And so what we're going to do is we want this Q point to get closer to P, just like on that Desmos thing. And so what we're going to do, we need x to get closer to C. And so we're going to take the limit as x approaches C of this slope, right? So because it'll change as it's sliding down all the way. So that's what we're going to do. And I know this doesn't look exactly the way it did with the way you memorized the difference quotient, but it is the same thing. You learned it as x plus h minus f of x all over h. This is just another way to write the difference quotient when we're taking the limit as x goes to c of that slope. All right, so let's do an example. We're going to find the slope of the line tangent to this curve, f of x equals the square root of x plus 4. And we're going to find it at this point P, which is 5, comma 3. I start by drawing the curve. I'm going to draw my little sketch. If you remember, the square root of x is just the sideways opening parabola, but just the upper half. The fact that it has an x plus 4 means it was shifted left 4 units. And so here's the curve of f of x. This is the square root of x plus 4. And then we're wanting to know what the slope is of this curve when you're at this point 5, comma 3, which would be this point there. All right, so what you want to do is you want to label any other point on this curve. I went over here. You didn't have to. You could have extended this out and done it more, but I'm labeling this point x, comma f of x. And I want to find the slope of this line, and then I'm going to take the limit as x gets closer to 5. So the slope will end up being, the slope of the curve will be the limit as x approaches the x value of this point, so as x approaches 5, of f of x minus f of 5 all over x minus 5. I did y minus y over x minus x. All right, once you do that, that's just what you're going to do every time. What you're going to do now is you have something to plug into f of x. F of x is the square root of x plus 4, so we're going to plug that in. And so the first thing you want to do is look at it and go, can I plug a 5 in? Can I plug a 5 into x? That's how we do limits, right? Can you plug it in? But when you plug it in, you would get a 5 plus 4, which is 9, and square root of 9 is 3. So you have a 3 minus 3 on top, which is 0. Not an issue, except that when you plug a 5 down in the denominator, you're also dividing by 0. So you can't do this. You can't just substitute it in. And so we got to do some algebraic manipulation. I know you've been used to multiplying by the conjugate of the denominator when there's a radical in there. This time what you're going to do, it's a fancy little trick. You've got a radical in the numerator. We're going to multiply by the conjugate of the numerator, top and bottom. So the conjugate would be the square root of 4 plus 3. You change the sign, and I can do that as long as I multiply top and bottom by the same thing. The trick here is don't distribute this x minus 5 into the denominator, but do distribute, like go ahead and multiply out the rad x plus 4 minus 3 and the rad x plus 4 plus 3, but leave the x minus 5 still factored in the denominator. You do need to keep writing this limit as x goes to 5. I know it's a pain, but you do have to do that. Now, because I multiplied by the conjugate, then that means that it becomes a squared minus b squared on top. So I get square root of x plus 4 quantity squared minus 3 squared. And so that ends up giving you an x plus 4 and then a minus 9. And that simplifies to x minus 5. And so now hopefully you see why I said don't distribute this x minus 5, because it'll end up canceling with what's in the bottom. Just the nature of these things. All right, so the x minus 5's cancel. And now I am left with a 1 over the square root of x plus 4 plus 3. Can I plug a 5 in now and not get a 0 over 0? Why, yes, I can. I can plug a 5 in there, and that'll give me rad 9, which is 3. So you get 1 over 3 plus 3, which is 1 over 6. So that's the slope. The slope of the tangent line right here at 5, 3. If I were to draw the right now, that's the secant line, but if this guy were to come over and just be tangent to that point, its slope would be 1 over 6. So cool, huh? Nice. You just found the slope of a curvy curve. All right, let's do another one. Finding the slope of the tangent line to the curve of f of x equals x squared minus 5x plus 8 at this point 1, comma 4. You're going to take the limit. As x approaches, you're always choosing the x value of your point. So as x approaches 1, of f of x minus f of 1 all over x minus 1. And then what you'll do is you'll replace this f of x with this function us. So the limit as x approaches 1 of x squared minus 5x plus 8, and then a minus 4. The 4 is coming from when x is 1, y is 4. So that's what f of 1 is, and then you've got over x minus 1. We simplify the top. Now you've got an 8 and then a minus 4, which will leave you with a plus 4. Again, notice I'm writing the limit as x approaches 1 on every step. Then what you want to do, can you plug a 1 in? No, because you got this divided by 0, and you'll have 0 over 0. So let's see, can we factor? Can we factor the top? Two numbers that multiply to 4 but add to negative 5 would be an x minus 1 and an x minus 4. Oh, yay, because now our x minus 1's cancel, and you're left with taking the limit of x minus 4 as x approaches 1, and so now you can plug it in and you get a negative 3. Show you the picture. Here's the parabola, x squared minus 5x plus 8. There's the parabola. And here at this point of 1 comma 4, you've got a slope of negative 3. That's the slope of the tangent line to the curve at that point. As you go along this curve, the tangent line changes, right? If it had been a point over here, you're going to get a positive slope. Down here at the vertex, you'd get a slope of 0 because it would be a horizontal line. But here to the left, you can see that the slope is a negative value, so it makes sense that it's a negative 3. All right, here's your homework. If you parallel park on a curve, are you really just tangent parking? I say yes. All right, I hope you all are having a fabulous day. I want this one. Do, 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 do. Come on, behave for me. Behave. I hope you all have a fabulous day.